the data, right? Given whatever the data is, not from the data, sorry, how far are you, given the data, how far is the data from the mean? So to find the deviation, this is what you need to do, is you need to take the data minus the mean. Whatever your data is, minus the mean. And again, ladies and gentlemen, is always, as you will see later in 11.5, 11.6, and 11.7, is always the data minus the mean. It will never be the mean minus the data. Okay? It's the data, whatever the number you have, minus the average, minus your mean. Once you find the deviation, the third step is now we need to square the deviation. And again, basically, whatever the result that you find in step 2, you take that number and time itself. You square that number. Okay? And once you square the deviation, now we have to add those deviation square or square of the deviation up. We need to add all of the results in step 3. We need to add them up, which is the summation of the deviation square or square of the deviation. And then step 5, which is now step 5. This is where, or if they ask you for the variance, ladies and gentlemen, if they ask you for the variance, this is where we stop. Excuse me. This is where you stop. Step 5 is the variance. Okay. So how do we find the variance? We take the sum of the deviation square, or the square of the deviation. We take the sum, meaning you add them up, and you have to divide it by n minus 1. So whatever the result in step 5, this is your variance. Okay. And again, what is n? Which is n is the total number of data that you have, which is, again, we have to, because we find the sample, we have to take one less of the whole thing. So again, we have to take n minus 1. And to finish this, which is step 6, which is, again, to finish this thing here, we have to take a square root. We have to take a square root of the variance, which is whatever the result of step 5. If we take a square root, then that will give you your standard deviation. So again, step 6 is your standard deviation. So again, this is step 5 is your variance. Step 6 is your standard deviation. And I know it sounds confusing, or it looks like it's very complex, but bear with me here. Let's take a look at this example, and hopefully I can lead you to into just like I would do in class, and then we can see if you guys have question with this item here. So again, I have the step here for you guys, right, to find the variance and standard deviation, which is the step here. So let's take a look at this data, right? Given this data, right, find the variance and the standard deviation for the following data, right? So this is my data. Look at this thing here. It's kind of big, which is, again, I have 9 individual data, right? I have 9 individual data. And again, looking at this thing here, we know that the mole is 73, right? That appear the most, right? So looking at this thing here, which is, again, looking at this item, what do we have? Which is, again, what are my first step? So first step, if we have this data, the first step is we need to find the mean, right? We need to find the mean, which is, how do we find the mean? We take each of your data, add them up, and divide it by the total number of data, which is, as you can see, this is your ideal data. Why do I say ideal? Because your mean, and your mode is at the same location, meaning it's 73, right? If you take each of this data, you add them up and divide by 9, you will get 73. If you put this in order and you try to find your median will be most likely be 73. So again, and the mole, which is, again, mole is 73, which is, again, this is your ideal data. It will be very hard for any real data to be the mean, the median, and mole at the same location. But again, later on you will see that that is our ideal data. But now, once we find the mean, that's the first step. We need to find the mean. Once we find the mean, the second step is we need to find the deviation. Question?
No.
Yeah, I hear some voice. I don't know if we have a question or not. But now step 2 is we need to find the deviation, which is, ladies and gentlemen, this is what we need to do is we need to take the data, right? Whatever your data is always the data minus the mean, like I mentioned earlier. We take the data, which is my data is 79, minus my mean, which is 79 minus 73, which is everybody see that I have 79, which is my data, minus my mean, which is I have 6. Same thing go, I need to take 72 minus 73, which is again, why 73? Because 73 is my mean. So again, my 72 is my data minus 73 to give me -1. And again, 67, which is my data, minus 73, which is again to give me -6, which is again, basically all you do is you take each of your data, and then you subtract your mean, right? So again, you take each of your individual data here, which is again, each of my individual data, 73, 76, 70, 74, 73, 73. That's my individual data minus my mean, which is, this is my result. So step 2, that's what we have, which is again, for this particular data is a lot because we have 9 of them, right? But again, the math is not complex, right? All you do is take each of your data minus the mean. And ladies and gentlemen, later on, you will see that at this location here, step 2, if you add all of your deviation up, it will be equal to 0, because it will always have to be equal to 0. If the deviation is 0, meaning you are at the mean, right? So again, if you are negative deviation, meaning you are below the mean. And if you have a positive deviation, meaning you are above the mean. And again, the mean is the middle of your data. You will always have some data below, you will always have some data above, and they will each cancel each other out, okay? As you will see later when we get to the easier problem here. So once we have the step 2, the deviation, now what do we do with step 3? Step 3, we need to take the deviation and square it. What do I mean square it? Meaning I take this 6. Again, whoever have the mic on, please mute the mic unless you have question, and then unmute it for me. So again, looking at this thing here, what we do is we take this deviation, which is again, my deviation is 6, and I need to square them up, right? Which is again 6 squared to give me 36. And again, same thing go, I need to take -1 square, which is -1 times -1 to give me 1. -6 times -6 will give me 36, and so on and so forth. And again, at this location, step 3, all of your number should be, have to be, must be positive. And that's the reason why is because we square, once we square, whatever we square, a negative times a negative will give me a positive. And again, we want to get rid of the negative because, as you can see, 4. What does step 4 have, or what do we do with step 4? Well, step 4 tells us that whatever this number is, whatever the result in step 3, I need to add them up. I need to add them up, which is you add all of this thing up. And again, if you add this thing up, which is you take 36 plus the 1 plus the 36 plus the 0 plus the 9, so on and so forth, which is if you add them up, you have 92. Which is again, if you have 92, which is once you have this thing here, step 5. Step 5, this is what you need to do, which is you need to take the 92 divided by n minus 1. What is n? N is your total number of data, which is in this case, my total number of data is 9, which is 9 minus 1 to give me 8, and 92 divided by 8 to give me 11.5. So again, looking at this thing here, which is again 11.5, this is your variance. So if they ask you for the variance, this is where you stop. This is what you give them, 11.5. Okay? So this is your variance here if they were to ask you the variance. And now, how do we finish if they ask us for the standard deviation? Well, all you need to do is take a square root of the variance, meaning whatever the result in step 5, you take a square root. So if you take a square root of this thing here to give you